Hello student, let's discuss the question. In this question we have to find out the integral of the function. So I is equals to integral of tangent of 4x multiplied by dx. This is tangent of 4x. We can write this as tangent square of x square multiplied by dx. So this is tangent square of x multiplied by dx, and we can also write this as tangent square of x multiplied by tangent square of x, which is further multiplied by dx. And we know that the value of the tangent square of x is equals to secant square of x minus 1. So plugging the value here, so this become equals to secant square of x minus 1 multiplied by the tangent square of x, which is further multiplied by dx. Now multiplying this, so this become equals to secant square of x multiplied by the tangent square of x minus tangent square of x, which is further multiplied by the dx. We can separate the integrals from here. So this from here become equals to integral of secant square of x multiplied by the tangent square of x multiplied by dx, minus this from here is equals to the integral of tangent square of x multiplied by the dx. Let's say this is I1 and this is I2. So the value of I is equals to I1 minus I2. Now first we are solving I1. So I1 is equals to integral of secant square of x multiplied by the tangent square of x, which is further multiplied by dx. Now here we are considering let tangent of x is equals to t. We are going to differentiate this with respect to x on both sides. So this from here become equals to d divided by the dx of tangent of x, and this become equals to d divided by the dx of t. And we know that the differentiation of tangent of x is equals to secant square of x, and this become equals to dt divided by the dx. So from here we can say that the value of dx is equals to dt divided by the secant square of x. So plugging the value here, so I from here become equals to integral of this is tangent square of x multiplied by the secant square of x. Tangent square of x, we let that tangent of x is t. So this from here become equals to t square multiplied by the secant square of x multiplied by the dx. Dx is dt divided by the secant square of x. So here secant square x to secant square x cancels. So this I from here become equals to integral of t square multiplied by the dt. And here we know that the integral of x raised to the power n multiplied by dx is equals to x raised to the power n plus 1 divided by the n plus 1. So t raised to the power 2 become equals to t raised to the power 2 plus 1 divided by the 2 plus 1. This from here become equals to t raised to the power 3 divided by the 3. This is basically I1. So the value of the I1 from here is equals to, we let that t is equals to tangent of x. So this become equals to tangent raised to the power 3 of x divided by the 3 plus C1. So this is the value of the I1. In the same way we are going to find out the value of the I2. So I2 from here is equals to the integral of tangent square of x multiplied by dx. And we know that tangent square of x is equals to secant square of x minus 1. So we can write this as, this is equals to integral of secant square of x minus 1 multiplied by dx. We can separate the integral. So this from here become equals to secant square of x multiplied by dx minus 1 multiplied by dx. And we know that the integral of secant square of x multiplied by the dx is equals to tangent of x plus c. So the integral of secant square of x dx become equals to tangent of x plus c minus integral of 1 with respect to x become equals to x. Let's say this is c2 and let's say this is c3. So from here we can say that the value of the I is equals to I1 minus I2. Plugging the value here. So the value of the I1 is equals to tangent cube of x divided by the 3 plus c1 minus the value of the I2 is tangent of x plus c2 minus x plus c3. So simplifying this, we can say that the value of the integral is equals to tangent cube of x divided by the 3 minus tangent of x plus c. So this is the answer to given question. So students, in order to solve this, we use the basic concept of integrals. I hope you understood the concept well. Thank you.
Don't forget to like and subscribe.